In this video, I show you what are the steps that are involved in the laboratory in the manufacture of a crown and a bridge. Now, I had this unique opportunity of actually visiting a dental lab. The lab is called Precision Dental Studio and it's located in Kolhapur in the state of Maharashtra in India. And the owner is Mohit Suryavanshi. Mohit is the master dental technician for Ivoclar, Beaverdent, Predent and various other companies. He was very kind and he allowed me to actually watch what all goes on behind the scenes or the workings of his lab. So I've broken this video down into a few sections. The first one is all about the analog way of doing things. So take an impression and then right the way to the manufacture of the crown. Secondly, we're going to discuss the digital pathway or the digital method of making a crown and a bridge. And thirdly, a combination of all of them. So let's first have a look at the analog way of how a crown or a bridge is manufactured. Now I must mention here that it wasn't possible for me to observe a single prosthesis being built right from the first stage to the final stage, but I have showed all the steps that are involved. So lab work, the jobs might be different, but the steps are essentially the same. So let's get started. The journey begins from here. Evaluation of the impression. Check if all the areas have been covered. Check if there are any air bubbles. Once it's been passed, then we start mixing the stone plaster. We set it on the platform on the weighing scale so that we get an accurate amount of stone plaster powder and the water to go in it. So here you can see he's measuring a very precise amount of powder, adds in another increment, and then takes a very precise amount of the water as well. Places it in there slowly and starts doing a little bit of a hand mix to initiate the mixture. And once that is done, he puts it into this little mixing machine. This was interesting when I saw it because once you put it in the machine, he takes this little tube, puts it out of the machine, and what it does is it basically pulls out all the air from that chamber, and the stone plaster is mixed under vacuum, so you don't get any air bubbles. You get a very smooth consistency. And this is another impression where you've got, as you can see, it's made of putty and wash, and he takes it out of the mixing machine and starts to pour it onto the impression. And he is using a platform that vibrates, so when he actually starts to pour the stone plaster, the platform vibrates and it eliminates any air bubbles. It's interesting the way he does it. He puts it on one side and then he allows it to flow to the other parts of the impression, and therefore that ensures that there are no air bubbles in your model. That's the model board. Once it's set, and he starts to slowly take it apart from the impression, doing it very gently, and there we go. That's the impression taken out. A good model. It doesn't have any air bubbles, and now it looks all rough on the edges, so we're gonna try and make it smooth. So we use a model trimmer here, and this one is got a rotating disc with water constantly flushing it. So he's basically trying to remove all the rough edges from the sides. Take it apart, takes it off in several increments. And he also trims the base because he wants to try and make the base of even thickness. So there he's trying to show that the base is even on both sides. Gives it some final finishing touches. And that looks like a well-trimmed model. Now, what about the inside? Now, this is a grouter. This allows us to trim the model from the lingual side in this lower case, or it could be an upper model as well that you're trying to take off the palate from it because you only need the shape of the arches and not anything else. So that's the machine that's used to trim away any excess. Once the model is all casted up and ready, now it's time to make the dies. Now we can see we're marking with a pencil as to where the cuts need to be, and this is a pinning machine. It's getting plugged in, and you can see the platform basically goes up and down, and there's a burr on the underside of it, and there's a light on the top, and that light, when it touches the part of the model, you get a corresponding hole on the underside when you press the platform below. So you can see the light comes on, he presses it, and you start getting holes at the bottom. Now that's where your pins are going to sit. That's the light, and he presses it, that's the hole right on the underside by pressing it, and those are all the holes done. Now the holes are all completed so that you can put the die pins in it, and it's got a selection of various types of pins. Some are single, some are double, and those little red bits are covers essentially that fit on them so that you don't get any plaster into them. Takes a bit of glue, puts it on the pin, and inserts it into the model. He's doing that for various other teeth, and he's got a little double pin there as well. He's doing the same thing, puts a bit of glue on it, puts it in there, and now he just put actually the sleeve. There we go, he's putting the sleeves on it, and that red little bit is to avoid getting any plaster flowing into that tube and getting packed. Once that's done, that's the finished way, and then he takes the model and starts making some grooves into them. These grooves, I believe, are for getting the orientation of the model to the base so that they both fit accurately together. So he's making various grooves, so there's only one way that the model can fit onto the base. And then he takes a little saw, and you can see he's starting to cut the dies. That's a few cuts done. Has to do it very accurately. There's a lot of skill involved in this, as you can see. Doing it slowly, there we go, and those are the dies getting separated now. He's made all the cuts, and he's starting to pick them off the base, and they fit perfectly back. There's only one position those dies can actually go back on the base, and if you look at the base carefully, you can see the metal inserts are in there. Now this is the next very critical step where he's trying to ditch the models. Now I'm trying to focus here, and as you can see, my camera doesn't focus very well at a close distance, so I have to zoom out a little bit. There we go, and you can see he's using a little round burr on the straight handpiece and trying to ditch. So he's trying to basically define the finishing line of that prep. You can see how careful he has to be. He can't trim any part of the prep at all. So that's all done, and then the model is getting cleaned. This is a different model, but it's the same thing. Now this is a finished model, all the dies are cut, it's been ditched. To get the model clean, he's using a steam cleaner, free for any debris, and you can see this is ready. Now sometimes just want to give it a little push on the underside to get the dies out, and that's our prepared die. And the first step is to get a little hardener onto the die. So that's a bit of hardener going on. And then he's also going to use a separator as well. Now I'm not sure, to be honest, which one he used first, either the hardener or the separator. And the other one, he's going to take a little brush. That is the separator, I think so, yeah. And then he dips it into this pot of wax. Now what this does is it allows an even coat of wax onto the prep. It hardens quite rapidly, and he's going to pick off the excess that's gone beyond the finishing line of the prep. Trim it all away. There we go. And now you can see he's got a nice little coping. Now you can use that wax up for depending on what you're doing. You can use it for metal coping, and you can cast it up. Now in this case we're using this as a Emax crown. So this is the critical part where you can see it's a very skilled job. He's got a heated instrument and he's taking some wax and actually manually adding all the wax onto the prep. This is very skilled. I've tried to do it. I often do it just to get just because I have an interest in it, and I get to learn a lot about the shapes and anatomies. If you've got the time, I highly recommend this process. Buy yourself a waxing machine and get some nice little wax. You can do your own wax up, but that's how the lab technicians do it. They're obviously very, very skilled at doing this. As you can see, it takes a lot of time and a lot of skill to get a good wax pattern. Now that's the wax pattern that's been finished, and he's just using a little carver. This is going to be an Emax crown, a press technique. So this is what we're going to be discussing in the next few steps, how to make a press Emax crown. That's the crown ready. Now let's assume this is our wax pattern and it's going to be invested now. So the wax pattern has had some sprues placed on them. The one on the right is, I think, a crown, or the left ones are a crown and the right side is, I think, a veneer. And so once it's all done, we put the rings around it and we start putting the investment material in it. So this is the investment material. It again comes in the form of a powder and a liquid, and as you can see, it needs to have a precise amount of water powder ratio and gets put into the mixing pot, the right amount of liquid, and we put the powder into it. So you put one measure, he's going to put another measure in it. So again, it's a lot about precise measuring, correct water and powder ratio. Gives it a bit of a hand mix just to get it going. And this is the machine that actually mixed the investment material. It gets put in there. I think it's got a vacuum pump in it, so the air goes out of it and the investment material is getting mixed in this machine. So it gives you a bubble-free mixture. There we go, that's all done and mixed. And then we start putting it into the ring. There's one ring that's being filled up. Put it on the side. And actually you have to paint on the wax pattern with the investment material. So here you can see he's taking a little brush and he's painting the investment material onto the wax pattern. There we go. Once that's done, then you put the rest of the material into the ring. This is obviously done in a way that avoids incorporating any air bubbles. Put the caps on it. And we basically wait for the whole thing to set. Now, while the thing is setting, we preheat our furnace, get it up and running, and I think it needs to reach a temperature of about 900 plus degrees. Here's our investment material all ready. Gets pushed out of the ring. The lids are also taken off. That's our ring ready to go into the furnace now. And remember, the furnace is preheated. and you take these rings into the furnace. There you go, that's one done, and there's the other. Now obviously what's going to happen is that the heat in the furnace is going to melt away the wax in there. After a sufficiently long, the wax would have all melted away. They're taken out, and while it's still hot, this is our Emax press system. So we put a ingot of Emax in there and put a plunger in there, and take the hot ring, put it into the preheated furnace, and that furnace basically is a vacuum furnace, so it takes away all the air from it, and that ingot that got placed before the plunger actually pushes that ingot when it melts at a certain temperature. Well, it doesn't actually melt, it softens and gets pushed. It gets pressed is the right word. That's the word I want to use. It gets pressed into the area where the wax has been removed. And then you let the rings to sit on the bench, let it all cool down. And here we're trying to retrieve our material, the pressed material. So as you can see, he measured it correctly, and he's using a broad disc to try and slowly cut away into the ring. There we go. So that's the material that's on the inside. The pressed ceramic material is inside this. Now, how do they get rid of the investment material? That's how they do it. They take it into a sandblasting unit, and you can see a little bit better there. The sand is essentially removing all the investment material, and you're starting to see the pressed material on the inside. Kind of hard to see, there's so much of sand floating around everywhere. I asked him to open the window just for a quick bit. So now all the investment material is gone. He's cleaning up the final bits. There is a crown. So once it's all cleaned and taken out, you remove the sprue by just cutting it off with the disc. And there we go, that is our crown. Taking off the button. This is removing some excess, giving it some smoothing. As you can see, it's a lot of precision. There's a lot of precision involved in all these steps. Now once that's all done, what remains is the glazing and the staining. So he's taking the crown and he's applying some glaze on it. A nice even coat all around the crown. That gives it the shine. And once you've done that, to give it some kind of a natural looking appearance, take a bit of stain and apply it to selected areas of the crown to give it that natural look. You can give it a very basic look depending on what the requirement is, and you can go full on with lots of occlusion stain and the rest of it. And there we go, that's the final fit of the crown. I actually should have showed a plaster model, but I'm just showing you a printed model. As we saw in the preceding video, there are a lot of errors that can be incorporated during the analog workflow. To name only a few, and I'm sure there are many of them, you could have errors during the impression taking, the improper mixing of the putty, wash, the alginate or whatever material that you're using, or there might be errors when actually pouring the impression, air bubbles getting incorporated, the wrong water powder ratio. So there's a lot that can actually go wrong in the analog workflow. The other one being, there is no way of actually storing that impression. I mean, you might store an impression for a long time, but how hard is it to actually store physical impressions or models for a long time? It occupies so much of space. In the digital workflow, the scan data can be stored on the computer or whatever storage device that you're using. And at a later date, if you decide that you want to manufacture that particular product again, you just bring up the same file, the scan files, and actually start making the product. You don't have to go back to taking a physical impression. You can use the same scan again. So there are many such advantages to digital workflow that we're going to discuss in the next section of the video. So follow for part 2. What's the part 2?